This video is for chapter 12. We're going to reproduce the chi-square distribution graph that I found on the internet. It's important to know what's going on there, especially because the guy who built it programmed the probability density function in a way that I didn't know how to program. And it's a good exercise before starting the practice questions after the first section of chapter 12 of Levene, which was the chi-square tests for comparing two groups. This is the probability density function built in MathCAD. I imported it here because I didn't know how to do it in any other way. Here's the way it looks in Russian. Плотность вероятности, and here will be replaced by K in the English version. Распределение хи квадрат звучит по-идиотски. Anyway, we're going to go back to the English version, and this is what I rebuilt. This is the probability density function, and that's the one programmed using the exponent function in Excel and gamma ln. All other gamma functions would not do anything else, anything useful for this graph. So what we're going to do, we're going to start with the values of x, which are going to be the horizontal axis as usual, and in the chi-square distribution graph, the horizontal axis is actually chi-square. We limit ourselves by 20 values. That'll be illustrative enough. We're not going to start with 0. We're going to start with 0.001 1,000th. Add 2, and then go in increments of 0.2 all the way to 20. We're going to do this first. And then do the probability density function. Almost there. 6, 8, 20. Okay. This will give us the increments for the chi-squared axis. He also used chi-squared distribution just to show the percent of curve area right to the right of x, but this value actually is not going to be used in the graph. This pink column is completely useless as far as graph is concerned, but it's just done for reference. We're going to go all the way down to 20. Once again, we're getting the values for probability density function, which are programmed with this formula. And this one is just showing what's over here. We're going to have degrees of freedom as a variable, which is controlled by user input. And we're going to need this to change the shape of the graph, because in chi-square distribution, what matters is the degrees of freedom and the p-value. Okay. This is what I was after. Going too fast. These are the inputs that affect the value of probability density function. And like I said, this is just for illustration of the percent of the curve area. That's it. we're going to use the area chart for this exercise. Now let's expose the probability density formula here. What we need to do is select data. And first we're going to select probability density function. This will be called chi-square depending on degrees of freedom, something like that. It's good enough. And we're going to select the probability density values. Here, what we're going to need to do is, for the horizontal axis, we've got to make sure we've got the correct values, because we can control them in the way that we want. Okay, we've got 20 here, that's what we wanted, and these are the values a little over 15 maximum here that are calculated given 5 degrees of freedom. This is we're done with the data. Now we need to pretty up the graph. Just to experiment, we can change the number of degrees of freedom and see how the graph changes. Let's see, maybe I should make it a little smaller so we can see the change on a full screen. Let's go back to 5, do 12, something like that, do 9. So it's working. Going back to 5, it's easy to see if we take these values, which I have just done prior to starting the video, and align them here, and then simply sort them by value. This is the greatest value for degrees of freedom of 5. Let's bring it up here. 0.154. That's what we're looking at here. It's around this area here. So that's what we've got. Now let's format the axes a little bit so they're better understood. Something like that. Let's do 5 here. Get that? No, let's do 10. 2, 4, all the way to 20. This is good. And that's about it. This is the chi-square values on the horizontal axis. That's pretty much enough formatting for us. Numbers are general. We're not going to change anything. 3D format, we're not interested. And just for the heck of it, let's see what it's going to look any different. I doubt it'll work in any way. No, I didn't. Doesn't make any sense. Okay. So the trick here was to program this probability density function in Excel, which is done in this manner. And that's the trick. Everything else is self-explanatory except for this exponent with gamma, and with the logarithm of gamma. So self-canceling exercise, but that's the way it's done. Okay, this is about it. Let's change once again degrees of freedom. And if you do 1, as we will in many exercises after first section of chapter 12, it'll be a really ugly chart like this. 2, then 3, 4. We're not going to see that all that much. So 5. Let's save this and stop the video. Okay.